In this video we have a couple word problems and we're going to use right triangles to figure out all the information that it's asking us to find. So in this problem, Jennifer and some friends are playing softball at a park and we need to label the diamond that they're playing on. So here's the diamond that will represent that, and I'm going to label all the bases. So we have home plate down here, this is first base, second base, third base, and then back to home. Our problem said that there's 55 feet between each of these bases. So there's all of those labels. And then it also says that the running paths create 90-degree angles. So there's all of our 90-degree angles. Now Jennifer's asking for the distance between home plate down here and each of the bases. So it looks like from home plate to first base, that's 55 feet. And then from home plate to third base, that's also 55 feet. And then from home plate to third base, that's also 55 feet. But we need to figure out the distance from home plate to second base. That's going to be a little bit harder. So I went ahead and drew a line connecting those, and that's going to be our distance, and we don't know our distance, so I'm going to make that x. But what I did right here now is create a 90-degree right triangle. So here's that triangle, and then I could also label this side 55 as well as this bottom side 55. These are going to be my legs of the right triangle, and then x is going to be my hypotenuse. And I could use my Pythagorean theorem here to solve for x. So I take both of my legs, which are going to be 55 down there and then here, and I need to square those and add them together, just like our formula says. We take a and b, square them and add them together because they're our legs. And then I'm going to set that equal to the hypotenuse, which we also need to square. And remember, the hypotenuse is going to be across from the 90-degree angle. It's the longest side of our triangle. So this is going to be x, and we square. So now I'm going to actually do the squaring of 55. Those both give us 3,025, and now we're going to add them together. That gives us 6,050. And to get my x squared by itself, so it's just an x, I need to take the square root of that, which means I have to take the square root of this side as well, and then I'm going to get my answer. That's going to be approximately 77.78, and that's in feet. And I believe that's all we had to do for this problem. Alright, now this problem with Matt is a little bit more complicated. He's building a staircase for a client, so I'm going to draw out a staircase situation here. Now in no means this is accurate to scale or anything like that. It's just a diagram that we could use. So we have the stairs, the second floor is up here, the first floor is down here, of course, and I'm going to add in all the information that we're given. So our problem said that our stairs were 11 inches wide, so the width is going to be right here. I'm going to add in a couple of those. That's going to be like the part of the step that you actually step on. That's going to be the width. Okay, those are all 11 inches wide. And then the height, it says, is 7 inches high. And that's going to be this part of the step right here. So I'll go ahead and label a couple of those. Okay, that's how high each step goes. And then lastly, it says from the first floor to the second floor, that's going to be 154 inches. So this dotted black line here, which I'll make orange, that distance is going to be 154 inches. And part A is asking, how many steps does Matt have to build to get from the first floor to the second floor? Well, we know that we have to go up a total of 154 inches, right? Well, how tall are each of these steps? 7, right? 7 inches. So how many of our 7 inches go into 154? That means we have to do division. 154 inches divided by 7 inches is going to be 22, and that represents steps. That's how many steps we need to build to get from the first floor to the second floor. Now that we know how many steps we need, we're going to use that to find part B, and part B is asking for the horizontal distance needed to build the staircase. That horizontal distance is going to be this part down here. Okay, we don't know what that is, so we're going to call that x. And now that we know that we have 22 steps, it means that we could take 22 and multiply 11 times, because we need 22 of those 11-inch spaces, right? So that's going to be 242 inches, and that would represent x. to part C. Part C is saying, imagine we had a railing built in here. So if I was going to put in a railing, I don't know, maybe it'd start right up here above the first step, and then it's going to go upwards and then end somewhere up here above the top step. Well, let's imagine that I drop this step down. Okay, I'm sorry, not the step, but drop down this railing. That would fall right onto the steps. So I'm going to draw in this brown line here, which represents my railing, and if I move it down, it looks like we create a triangle here, right? In the brown side right here, that's across from a 90-degree angle, so we could call that our hypotenuse. And then we have 154 here and 242 on this side. Those are going to be my legs. We're being asked to solve for this side right here, which is going to be my railing. So all I have to do is use the Pythagorean theorem here, and I could solve for the hypotenuse, which is really the length of our railing. So I wrote out my formula here, a squared plus b squared. Those are going to be my legs squared, so I'm going to write in my legs. Then I'm going to set this equal to the hypotenuse right here, which is going to be x, and we square the hypotenuse too. And x is going to represent the length of our railing, remember. So the first step I'm going to do is, well, the second step, I guess, is to actually square these numbers. That gives me 58,564 plus 23,716 equals x squared. Now we could add these two numbers together. That gives us 82,280. And then I have to get rid of that squaring of x. So I'm going to take the square root of this right side, which means I take the square root of the left side as well. So I'm left with x equaling about 286.84 inches. And this is approximated because we have a long decimal. So that's going to be roughly the length of our banister, or our railing.